Good morning, children. Welcome to the computer class. Let's start the chapter number 3, and this is the unit number 2 of chapter number 3, logic gates. Okay, children. So, in this video, we will be learning about Boolean, algebra, Boolean, law, and different types of logical circuits. Okay, so this is the important chapter for the board examinations. So let's start. So my first topic is Boolean algebra. So children, the mathematician and the scientist have spent centuries to find the relationship between mathematics and logics. And the dream came true when George Boole discovered a link between mathematics and logic in the year 1854. Okay, so Boolean algebra means, children, this is the logical operation, logical circuits. Okay, so Boolean algebra, which became useful to solve the logical problems in the mathematics, is known as a Boolean algebra. So Boolean algebra deal with either two values, okay, true or a false. 1 means true and 0 means false. In other language, 1 means on and 0 the condition for off. Okay, so Boolean algebra deal with only two variables, true or a false. And this is yes. So he used relay in the circuit to show the application of two-state switching on and off phases of relays. So this is the reason why Boolean algebra is called the switching algebra. Okay. So now the Boolean algebra basically work on three operators: and, or not. Right? The first logical operator is logical not operator. Logical not operator. So this operator provide the complement of a given number. Provide the complement of a given number. For example, suppose that here I am giving input is 0, then output is 1. Okay? And now when we give the input is 1, then output will be 0. It means this is the complement of the given input. So logical not operator provide the complement of the given binary value. It is represented by dash or a bar. Right? Okay. Next one is logical or operator. So children, this operator deal with binary value. Okay. Not operator work on a single operand, and logical or operator work on a binary operand. Okay. You work on a binary values, means 2. It is represented by plus symbol. This symbol is known as a logical OR in Boolean algebra. Okay, and the condition for logical OR operator is, children, 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, and 1 plus 1 is equal to 1. So in this expression, the output is 0 only when all the operands are 0, otherwise 1. Okay. Look at this truth table for a OR operator. So OR operator, the condition for a OR operator is, if any one condition is true, then output will be true, otherwise false. Or in other language, when both condition is false, then output is false, otherwise true. Right? So next is logical AND operator. So children, logical AND operator, this operator result in a product of two more binaries value. Okay, it is represented by dot. dot symbol. Look at this truth table for AND operator. So children, here A and B, these are two inputs, okay, and A dot B, this is the output, okay. And the condition for AND operator is when both condition is true, then output will be true, otherwise false. Look at this condition. If A is equal to 0 and B is equal to 0, then output will be 0. Now A is equal to 0, B is equal to 1, but output will be 0. Why? Because AND operator, the condition for our AND operator is when both condition is true. Look at this last condition. When both condition is okay, then output will be true, otherwise false. So I hope you understand what is the use of AND or a NOT operator. Okay, so NOT operator work on a single operator. It is the complement of the given input. OR operator, when both condition is false, then output is false, otherwise true. It is represented by plus symbol. NOT operator is represented by dash or a bar, okay, and AND operator denoted by dot, this symbol, and the condition is when both condition is true. When both condition is true, then output will be true, otherwise false. Okay, so I hope you understand. So now the next topic is Boolean postulates and the Boolean law. Okay, so just like a mathematical algebra, Boolean algebra also use some properties and a sum law, okay, to simplify the given expressions. Okay, so some of the postulates and laws are given below. So first law is property of 0 and a 1. Okay children, property of a 0 and 1. So first property is A plus 1 is equal to 1. It means when we add the 1 with any variable, okay, using this operator, means plus, it means OR operator, then output will be 1. So A plus 1 is equal to children 1. Now second law is A dot 0 is equal to 0. It means when the variable is multiplied by the 0, then output will be 0. Next one, when we add the 0 with the variable, then the output will be A. Or when we multiply the variable with 1, it means the output will be A. So this is the property of a 0 and a 1. Right? Next property, this is the important property, complementary law. Okay, so children, in this law states that a variable added to its complement, then the result in 1, the variable multiply with its complement, the result will be 0. Means A plus A dash 1, when variable is add with complement, then the result will be 1. Okay, when we multiply, then output will be 0. This is the complementary law and the important law. Okay, next, idempotent law. So this law states that the variable either added or a multiply with same variable. Okay, look at this example, A plus A, these are two same variables, then the output will be A, or a multiply by the same variable, okay, and the output will be A. So it means this law states that the either variable either added or a multiply with same variable will result in the same. A plus A is equal to A and A dot A is equal to A. Right? Next law is involution law. So this is the complement of a given input. Okay, it means that A dash complement of the complement is equal to the original value of A. So this law states that the double complement of any variable result in the same variable. A dash dash is equal to, या double complement is equal to A. Okay, so this is the involution law. Next, commutative law. So commutative law say that कि A plus B is equal to B plus A or A dot B is equal to B dot A. Okay, very easy. A plus B is equal to B plus A and A dot B is equal to B dot A, right? Next, distributive law. So distributive law, it means A in bracket B plus C, this value is equal to A dot B plus A dot C. Next, A plus B, second law, A plus B C is equal to A plus B in one bracket and A dot plus C in another bracket. So this is the distributive law. Next law, associative law. Okay, so this law states that A plus in bracket B plus C, this value is equal to A plus B in one bracket dot C, or A dot B dot C is equal to in bracket A dot B in one bracket and C, right? Next is absorption law. So absorption law say that the A plus B, A dot B is equal to A. Okay, now the question is how A plus A dot B is equal to A. So here we use the sum Boolean law. So look at this, A plus A dot B. So tell me children, here the common is A. A is common. Now here 1 plus B, and you know that the property of 1 plus B is equal to 1. So A dot 1 is equal to A. Clear? How to A plus A dot B is equal to A. So I hope you understand. Next law is A plus B is equal to A. Okay. Now A dot A multiply A with A dot A plus A dot B. So you know that children, A plus A is equal to A dot A, it means A plus A dot B. Okay. Now we common A, so 1 plus B, so A 1 plus B is equal to 1 and A. So it means A is the final output. Okay, this is the absorption law. Okay, so this is the first part of this chapter. Thanks for watching this video. Thank you.